Today I'm going to be making a video on nonlinear relationships block 4, so you can watch this if you need help with your assignment this week. We're going to continue on with what a linear and nonlinear relationship is, or what that looks like. So today we're going to start with an example of oranges in a row. So it says, look at another example. Well, first of all, this is going to help you with question 1, if you can see up here in the top right corner. Look at another example. You work in a grocery store in the produce section. Your job is to create displays of fruit and vegetables. Your manager asks you to put oranges flat on the table and form a triangle. You want to determine how many oranges can be put into the arrangement. You begin by analyzing how many oranges are in each row. So here we have the picture of the oranges. As you can see, they're in a triangle. The top one has 1 orange, then the next row has 2, the next row has 3, 4, 5, and so on. So it shows up here the row number, and you can see all of the 1, 2, 3, 4, 5, 6, 7, 8, 9, and the number of oranges in that row. They're all the same thing as the row number. So row 4 has 4 oranges, row 5 has 5 oranges. Can the relationship between row number and number of oranges in that row be represented by a linear function? How do you know? Well, remember, a linear function goes up by the same amount every single time. Looks like our difference here between 1 and 2 is just 1. The difference between 2 and 3 is 1. The difference between 3 and 4 is 1, and so on. It's going to keep continuing that pattern. So it looks to me like this one is linear. As each row number increases by 1, the number of oranges in that row increases by 1. Because the rate of change is constant, the relationship is linear. You can see this in the graph of the data. So if you look, this graph is creating a straight line going up. That makes this one linear. So remember, if you need to pause this video and copy things down, that's completely fine. Do that so I know you can finish up your packet. All right, we're going to move on. The manager wants to consider the total number of oranges needed for displays of different sizes. You organize the data in a table showing the number of rows in each display and the total number of oranges in the display. What will a graph of these values look like? How do you know? By looking at the table of values. So it looks like we have the first one, the first orange. The first row is just 1 orange. The second row looks like now we have 3 oranges. Then the third row, we have 1, 2, 3, 4, 5, 6 oranges. So it goes 1, 1, 2, 3, 3, 6. And then the next one will be 4, 10, 5, 15, 6, 21. Now let's look and see if this difference is the same every single time. Between 1 and 3, that's a difference of 2. Between 3 and 6, that's a difference of 3. So I already know it's not it's not the same. What we're going to have is something different. So what would a graph of this look like? If something was increasing always, but it was going up by a different amount every single time. Well, the graph of that situation would not be linear. It would not be a line. It would look something like this. You can see that the graph is still going up, but every single time it's increasing by 1. So that makes our graph a curve. This is an example of a nonlinear relationship. It does not make a straight line, it makes a curve. If you can see here, the number of rows is on our x-axis and the total number of oranges is on our y. That will be the same thing for any number of any table. The one on the left is always the x, the one on the right is the y. So again, this one is a nonlinear relationship. They do not increase by the same amount every single time. Remember, this is going to help you answer question 2. So this page will help you answer question 2 in your packet. Now it says use the graph and table to solve this puzzle to show your understanding of some important ideas about functions. This is going to help us with question 3. So filling in the blanks is going to help us with question 3. So if we look at the graph and the table together, the first thing on the puzzle says the function of the rows of oranges to total oranges is not blank because the points on the graph do not make a straight blank. So when I see this word here, straight, I know we've been talking about straight lines. So I think I'm going to put in a line there. So now it says the function of the rows of oranges to total oranges is not blank because the points on the graph do not make a straight line. Now, if the points don't make a straight line, then we know that it's going to be nonlinear. It's going to make a curve. But we can't put not nonlinear because that's just a double negative. It won't work. What we have to put is the total oranges is not linear. Same thing as nonlinear. It's just replacing one letter, not and non. So the function of the rows of oranges to total oranges is not linear because the points on the graph do not make a straight line. Instead, the shape of the line connecting the points is blank. So instead of a line, like we said, it makes a curve. So the shape of the line connecting the points is curved. When you look at the table, the output values blank have the same difference. So it looks like it's either do or do not have the same difference. So if we look at the table, between 1 to 3, it's a difference of 2. Between 3 to 6, a difference of 3. Between 6 to 10, a difference of 4. Between 10 to 15, a difference of 5. Those are not the same differences every single time. So the output values do not have the same difference. This is another reason the function is blank. So when we have all of our differences different, then it makes our function non-linear. So our table, the function of the rows of oranges to total oranges is not linear because the points on the graph do not make a straight line. Instead, the shape of the line connecting the points is curved. When you look at the table, the output values do not have the same difference. This is another reason the function is non-linear. And the last page. The pattern in the displays is similar to the ones you saw in the triangular patios. The nonlinear data form a pattern but do not have a constant rate of change. Now write an equation to represent the data in this table. Use the animation to assist you. Keep thinking, how can you determine the number of oranges in each display? So I want you to take some time here, pause the video, think about what kind of equation we could use with n and t. N is the number of rows, t is the total number of oranges. See if you can pause the video, come up with an equation. Okay, now that you've paused the video and come up with an equation, let's check to see if you were right. The equation that they came up with is t equals 1/2 times n times n plus 1. So if you see on their process, the n they put in here in the middle. So 1/2 times 1 is 1/2 times 1 plus 1, 2. 2 times 1/2 equals 1. Then they put in the 2 in the middle. 1/2 times 2, well, that's just half of 2, which is 1, times 2 plus 1, which is 3. So 1 times 3 gives us 3. Same thing here. Half of 3 gives us 1.5. 3 plus 1 is 4. 4 times 1.5 is 6. Now it says down here, one way to write the equation is shown here. Click the hint button to see how it works. So if I click this hint button and watch the animation, it can show us how this works. So they added oranges. The first one started off with 1, and then they added 1 more. The second one started off with 3, so they added 1 more to each row, or 1 more to the bottom row, but then they had to add these other 2 to make it equal. Same thing here, they added 1 more to the bottom row, but then they had to add the rest to make it equal. Now the reason we divide by a half or multiply by a half is because we don't want this whole thing, because that would be counting our oranges doubled. We divide or multiply by a half because we only want these darker oranges here. We don't want these lighter ones. All right, that is nonlinear relationships block 4. Remember, you need to also do the reinforced questions at the end. That's just not going to be on Agile Mind. Thanks for watching.